What does the del keyword actually do? If you aren't sure, you're not alone. How about in this specific scenario? It is more subtle than you might think. Let's break it down. First, we define a variable. This variable holds the value 10. If we use the del keyword on this variable, what do you expect to see? We assign it, we delete it, and then we try to print it. Running this code reveals the immediate result. Python throws an error. X is not defined. The del keyword has effectively erased the variable name. Think of it like this. You had the number 10, and it had the label X. You just ripped that label off. Without that label, you can't access the value. But what happens in this case? We have a list assigned to a variable called A. Then we create a second variable that points to the first one. Now variable B is equal to A. In Python, a reference is created for this list, and that reference is handed to variable A. When you set B equal to A, you are saying, give me a link back to that same list. Now, if you delete A, what happens to the data? Think carefully before we reveal the answer. Let's see if your guess was right. Look at that. It still prints the values in B. However, if we try to print variable A, we get the familiar error, A is not defined. Yet, for B, the list is still perfectly accessible. Here's the secret. Setting B to A doesn't copy the list. It simply stores the address of where that list lives in memory. Remember, variables are just labels. When you remove one label, variable B is still pointing to the data. The underlying reference is still intact. Deleting A or B individually doesn't harm the data itself. Variable B still holds a direct pointer. So the list elements remain safe and sound. But of course, there's more to the story. I hope this clarifies how the del keyword truly operates. Stick around as we dive even deeper, especially into how it behaves inside a function.